Hey everyone, welcome back to Pine Hollow Auto Diagnostics. 2012 Mini Cooper at a local shop here. It's been here for months. Crank no start. So I started diagnosing cars for them. They made me a whole list of stuff that's been on their lot for a while. So this is going to be fun. 113,000 miles, N16 engine, naturally aspirated, and we've got a battery charger on it. So let's scan it for codes, see what happens. Alright, we're inside the Mini. First thing I noticed, there's a giant pool of water at the passenger's footwell, and the fuse box is right there. So that's not a good thing, but we don't know if that's the issue, obviously. Full code scan. In the ECM we have 2 faults. Let's just take a look at the faults. Power management closed circuit current violation, exhausted battery charge, so nothing crazy, whole bunch of stuff. Let's just start from scratch, clear out all this garbage. Keys on. We'll clear DTCs. Boom, boom, boom. It's nice to have topology. It's nice to have this speed. You can see all the modules in one screen. Which one have codes, which ones don't. Can't ask for much more than that. And this thing keeps powering down even though it's on the charger. We're at 15 volts. Maybe that's a little too high. I forgot to bring my Tornado 90,000, unfortunately. K-line fault. No communication with park distance control. Don't care. Let's jump into ECM. See if this thing will crank over, what it does. Data stream. Motor operating values. We'll do engine speed, battery voltage, throttle. Let's look at the adjustment factor. Just look at those 6. Okay, now it's down to 13 volts. It's a stick shift, and the shifter is all stiff, but let's just try to crank it, see what happens. Didn't expect that at all. Let's let it warm up. Let's see if it'll idle. Seems a little lumpy. Didn't expect that whatsoever. Alright, so it's warming up. I'm in OBD2 mode. You see our short and long-term trims. It's running a little rich. Minus 16%, minus 17%. Okay. If it starts and runs. Just let it run for a little bit. I'm going to ask the shop owner when was the last thing this thing ran? Or do I have to wait for it to die? I'm not sure. Well, just talk to the shop owner. He is as surprised as I am. He said he's never heard the car run. They have to push it in and out, tow it out of their lot. I mean, it starts and runs just fine. And start. Fires right up. That K&N air cleaner is definitely throwing off the fuel trims. About minus 20%. So, not the end of the world. That I told him you have to take care of this. This is going to cause massive issues. It could total the car if that fuse box gets messed up. But I guess that's it for this one. You got a couple more here to do, so we'll just keep moving. Alright, so a week later we're back in the 2012 Mini Cooper. The one that just started right up, no problems last time, even though it was a crank no start apparently for a month. And remember, there's a pool of water on the passenger's feet. So the shop here, they drove it in the shop, tore the whole interior apart, dried out the, they said there was literally 2 inches of water on the floor. They blew out the sunroof drains, apparently that was causing the flood in here. Put everything back together, and guess what? Crank no start again. So we're starting from scratch, did a full code scan. Again, there's no interesting codes. Before clearing codes, let me just try to crank it, see what happens. Okay, crank no start, that's good. Let's clear out all the DTCs. I do have the good battery charger on the car right now, the Tornado 90,000. We're at 13.5 volts, so no questions there about battery voltage. So only 2 codes left. Tilting sliding sunroof, controller. Let's try to crank it again. Not even coughing, no sputter, and then the starter shuts off on its own. Let me scan it one more time, all the modules. Everything's green, green, green. Almost everything's green. We do have a few codes that popped up. Relay wiper stage 1 for front wiper. So do the wipers work? The wipers do not work. So let me save this in a report, and then we'll start the diagnosis of why it's a crank no start. What are we missing? Compression sounds fine, and it ran fine before. So it has to be something electrical. We'll check for spark, check for injector pulse, you know, the basics, and see what we're missing. Alright, before we jump under the hood, I just want to take a look at basic OBD2 live data, see if this makes any sense. The throttle right now is at 58%. I'm not touching the throttle pedal. If I push the throttle, it actually goes down. That's kind of weird. Let's crank it, see if we see an RPM signal and a mass airflow sensor reading. We do. Okay, that's good. So the computer's alive. It's seeing a crank input. It's seeing airflow, spark, and fuel. Ignition coils and injectors. Look up a wiring diagram and see where we want to hook up the scope. Alright, let's figure out where we want to probe these ignition coils and fuel injectors. So I'm looking up wiring diagrams. Here are the 4 fuel injectors, and each one of them has an orange wire and a white wire coming to them. All the orange wires are spliced into this one tree, and it says terminal 87. Terminal 87 is just battery positive. So let's see where that comes from. Pins 7 and 4, or traces 7 and 14. They go to the oxygen sensors. So I'm not seeing a fuse or a relay. It just goes to the engine computer, which is very interesting. Does the engine computer supply power to the fuel injectors? That's crazy. Anyways, we want to probe one of the white wires. We'll pick fuel injector number 1, or whichever one's easier to get to. And the white wire goes to the engine computer. Just says fuel injector. So that's 1, 2, 3 fuel injectors right there. Ignition coils are right here. 4 ignition coils. Again, the green wires are all tied together. That's the battery positive feed. And again, I'm slightly confused because it goes here, 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 terminal 15 at the engine computer. So is the engine computer feeding power to these ignition coils? Again, that is crazy to me. There's no fuse, there's no relay. The power's coming from the computer. Maybe that's the way BMW does it. But anyways, we want to probe one of the control wires. So for coil number 1, it's going to be a white wire. So let me set up the scope, 2 channels, 2 control wires, fuel injector number 1, and ignition coil number 1. Alright, here we go. So again, 2 channels. Channel 1 is on ignition coil number 1 control, that's the white wire. Channel 2 is on injector number 1 control, that is also a white wire. The orange wire is the power feed. So let's crank it over, see what it does. Alright, got the scope rolling. So channel 1 is starting at 0 volts. Channel 2 is already at battery voltage, 13.5 volts. So that's terminal 87. Let's crank it over, see if we see any activity. Okay. Very interesting. So we definitely see injector pulse. It kind of smells like gas a little bit, but we see absolutely no activity on the ignition coils. How about that? So we have no spark at the moment. We do have injector pulse. Nice, clean injector pulse. Very consistent. No spark at all. So let's figure out why we have no spark. Let me set up another channel on the power feed to the ignition coils. I assume that's going to be 0. And if we provide a power feed, will this engine start up and run? Alright, I have a 3rd channel set up here on the green wire. That should be hot when the ignition is on. If it's not, the coils will all be dead. So let's turn the ignition on, see if that comes alive. If not, we can feed battery power to here through a fuse, just to be safe, and see, see what happens. Alright, so let's turn on channel C. It's going to be 0 to 20 volts. Right there. So we'll turn the key on. Check engine lights on. Nothing. Let me crank it. Obviously we have no power feed to these ignition coils. Let's set up. First I want to do a 5 amp test light just to be safe. Make sure there's no short to ground on that leg, because the engine computer, if it is feeding power to these coils, which is crazy, I've never seen this before, then it could be cutting out that power feed if there's a short on the line somewhere. So the 5 amp test light is a safe way to feed power to that circuit. If it lights up bright right away, we know there's a short to ground, we'll chase that. If it doesn't, we'll crank it over and see if these ignition coils actually fire. Alright, so here I have my 5 amp test light pair. First I'm going to feed 1 amp. So we're going from battery positive to here. There's no short to ground on that green wire, so I feel safe feeding it the whole 5 amps. And when the ignition coils fire, these might flicker a little bit, but we'll see what the feed voltage is with this green channel. That's why I have the scope on there. So now it might start if the test lights can provide enough current to these coils. So let's see here. Okay, so now I see the green and the red are both at 12 volts now, so the coils should have power. And the coil control wire, the blue channel, we'll bring it down here, is also a battery voltage waiting to get pulled to ground by the ECM. That's how it's supposed to be. So let's see if it fires up. See, fired right up, even with the test light. So we know the problem, or we know why it didn't run, because we had no power to the ignition coils. Now we need to figure out why there was no power to the ignition coils. So pretty neat. It runs off of a test light right now. We can see if the test light is flickering. Let me stop the recording. You can actually take a look at what the feed voltage is. So you can see the feed voltage does drop a little bit to about 10.5 volts. The ignition coils are firing just fine. That's pretty neat right there. So that's a firing event. These are the other 3 coils. The injectors are firing. So let me save this waveform, and then we'll see. We'll try to figure out why the ignition coils have no power. So the test light's not even lighting. It's providing plenty of current to the ignition coils. No problems at all. So actually, you could leave the car like this, because it wouldn't be drawing any current if the coils had power on them all the time through a test light. But we need to figure out the root cause. So let's do a little more research, see where this engine computer lives, probe that green wire at the engine computer, and we'll see. By the way, if I take power away from the ignition coils, it stalls right out, of course. So I'm looking up the OE diagrams, and indeed, the engine computer gets power from a relay, and then sends power out through a transistor or whatever to the ignition coils. This green wire, pin 5 on X60211, and all the ignition coils have this green wire feeding them power from the DME. Crazy stuff. So we need to check this relay, this power input, and this power output from the engine computer. Easiest place to do it is probably right at the engine computer, which is, where is it? It says the left side of engine compartment, and the connectors are labeled here. So let's try to find this and probe at the DME. We're going to be looking for the green wire that feeds all the ignition coils, which is terminal 15, pin 5 on connector X60211, right here. So I was wondering if in live data in the ECM or the DME, if we have an ignition coil power output data pit, since that's apparently what's in charge. Nope. And this thing is Valvetronic, so that's why the throttle was all the way open at startup, but yeah, not very helpful. Alright, so trying to save some time here. Here's our engine computer. We're going after this connector. I see a fat green wire right there. That's the only one. So I'm not even going by pinouts, I'm just going by wiring colors. Have it probed, test light to ground. If I connect my 5 amp test light, feed power to this green wire, is this one going to line up or light up? It'll confirm wiring integrity, it'll confirm we're on the right wire. So let's see, hook this up. Yes, our test light lights up. So the problem here is the engine computer is not feeding power to the ignition coils. There are no codes, the wiring integrity is good. Why did it run for, a few minutes before? I don't know. Maybe the driver and the computer is cooked. There are no shorts to ground. All the current ramps look even on the scope. So what's the quick and easy solution here? These ignition coils just need an ignition power source. Not from the computer. It's not setting any codes. We just need to figure out, maybe, from this fuse box, maybe there's a fuse in here. That's ignition power. If you look at all these pictograms, find an ignition source here and just tie it to here and we'll be done. Alright, so I think we can easily modify the situation to make the car more reliable. So, what is the ignition power source to the engine computer from a relay? This red and green wire comes in on pin 1 on X60004. Red and green wire, that's this one right here. It goes to pin 1. I even double check the pins. Here's pin 1. So, I got that back probe. We'll put a little test light on here. That should come on when you turn the key on. This green wire is controlled by the engine computer. It's also an ignition power source. So what if we just connect this to this and have the relay feed the coils instead of the stupid computer? I think it should work perfectly. So let me plug everything back in. First we'll make sure this is an ignition power source, and then we can just safely connect the 5 amp test light between here and do the bypass here instead of from the battery. If that works, you just install a wire. It's all ignition battery power. It is fused because from the relay it goes through a 15 amp fuse, so that's safe. If there's a short anywhere, the fuse will blow and the computer should still be fine. So we're just bypassing the computer externally. I think that'll be a beautiful solution. Alright, here's our little baby test light from the red and green wire to ground. Let's turn the key on, or push the button to make the check engine light come on. There we go. That's not lighting up. Should it be lighting up? Let me scope this wire, see what it's doing. This is interesting.